Good morning, students. This is lesson 4-6. Let me share my screen with you. Okay, today we're going to be talking about formalizing relations and functions. Okay. Now, in lesson 4-6, it's sort of like reviewing and going over some of the material in a different way. The focus is on the pairing of X and Y and how they react to each other, also how they are grouped separately. But before I jump into 4.6, I wanted to review something from 4.4 that I didn't really go over in the video. And that's on page 272. It gives you these terms, continuous graph and discrete graph. Okay, let me kind of explain. In a continuous graph, if you're graphing information, then you can have points that essentially like um, are all right next to each other. I'm not doing a really good job of that, just making it messy. But with a discrete graph, when you graph your points, then there's space in between the different points. Okay? Now, the book example on page 272 was talking about cheese and milk. And it said basically what's the weight of a certain amount of milk per like container or something like that, or to make cheese. And the idea is since milk is liquid, you can put in just a few drops more and then you'll have a different point on the graph. A few more drops, you'll have another point. Okay. But when it said making the blocks of cheese, every block of cheese is like a pound, this would be like 1 pound and then 2 pounds and then 3 pounds. Because one is fluid, you can just add a little bit more fluid and it'll graph like continuous in the sense that every dot that you make on the line can represent an actual point of the weight of the milk. But since blocks of cheese all have a fixed weight, then there's space in between each interval, meaning that since it's something solid, it's not like you can just pour a little bit more cheese on. Okay. Now, generally speaking, with graphs, the points are considered discrete even if you draw a line to connect them. Okay. And generally speaking, on a graph, if you have points in between the points, then they're usually considered what we would call a fraction. Okay. Like, for example, if you have an ordered pair, 1, 2, that would not have a fraction on it. But if you had 1 and then 1.5, that does have a fraction, and that's kind of where your line will show up in between the squares on the grid. All right, well, let's kind of go into today's lesson 4.6. Now, I have some vocabulary for you, so go ahead and learn these words. A relation is a pairing of numbers into a domain and range. Domain is the independent values of a relation, usually given the letter x. Although, as I discussed before, you can use other letters if need be. The range is the dependent values of a relation, commonly known as y. And same as with x, you can use other letters if needed. And a function, sorry, it's a little fuzzy here around there. A function is a special relationship with exactly one number in the range paired to each number in the domain. Okay? Now, I feel like I'm telling you stuff I already told you before, and in a sense, I am. But we talked about the x and the y values and how we use them for graphing, but we called them the independent value and the dependent value. X is independent and y is dependent. So I have a little hint here for you to help you kind of understand today's lesson. And the hint basically just states, when we talk about independent and dependent values, we're thinking of x and y as pairs. So as you can see, I have pairs of x and y. Independent, dependent, independent, dependent, independent, dependent, independent, dependent. But when we use the terms domain and range, we're thinking of them as groups, okay? So in that sense, I think here's my domain, which are one value, and here is my range, which is another value. Now again, we're talking about the same things. We're talking about x and y, we're talking about ordered pairs, but the difference is when we talk about domain and range, we're focused more on them as groups than we are as pairs. So if there's a question asked, what is the domain? Then you would say the domain is 1, 2, 3, and 4. It's a group. I'll just name my group X since those are my X values. Now you don't have to, but I'm going to color code mine so that it's just very clear. Then the answer is, what is the range? The domain is, the range is 7, 4, 8, and 7. Okay. Now, I noticed that the number 7 occurs 2 times. So since it occurs 2 times, it's not necessary for me to write it twice. So I'm going to go ahead and cover that one up. Okay. Now, I'm going to call my range y. Okay. Now, in this case, when I have a domain and when I have a range, then I can show how they connect. Let's see. 1 connects to 7. 2 connects to 4. 3 connects to 8. And 4 also connects to 7. Okay? So that's how I would write my ordered pairs when I'm thinking of them as a domain and a range. Now, when I say independent and dependent, I think of them like this. When I say domain and range, I think of them like this. They're the same numbers. All it is just a different way of organizing them. Okay? So if I were to have these in a table, then I would write them as such. Okay. Now in the table, I can kind of look at them horizontally and I see the ordered pairs. So I think of them as dependent and independent. But the nice thing about the table is I can also look at them as domain and range. Okay, how they're separated. Okay, I hope this clarifies. So this video is for 4-6 part 1, and then I'll do a separate video for part 2. Thank you much.